In the modern world, copper is a key player. It's in our cell phones, in electric cars, in the pipes of our homes, and in the large power grids that supply entire cities. Its versatility, conductivity, and durability make it one of the most essential metals for society. Have you ever thought about where it comes from? The journey of copper is a story of engineering, geology, and chemistry. A saga that begins deep within the earth and ends in products we use every day. Let's dive into this universe and understand the industrial process that transforms rocks into a valuable metal. Copper is one of the best conductors of heat and electricity. It has exceptional resistance to corrosion. It is very flexible and malleable, and it can be recycled indefinitely. It is found in the Earth's crust, in the Earth's outermost layer, mainly in sedimentary rocks, and its extraction is a complex process that includes several steps. The first step is to identify areas with potential for ore deposits. This requires geological studies, sample analysis, and prospecting techniques to find locations where copper is present in economically viable concentrations. When a copper mine is found, everything is prepared to begin extraction. But before reaching the valuable ore, it's necessary to remove huge layers of waste material. In some areas, the mineral deposit reaches 100 meters deep, which requires the use of colossal machinery and tons of explosives. To extract the rock that contains copper, a huge drilling machine is used, which makes about 130 holes known as blast holes, at least 16 meters deep, which is equivalent to the height of a 5-story building. In each hole, a powerful mixture of ammonium nitrate and fuel is introduced, along with a certain amount of an explosive called ammonia, and then it is filled with stemming material. From a safe distance, an operator triggers the charges, causing the explosions to be detonated in series. Each detonation is so powerful that it could bring down an entire building. The time between each explosion is approximately 2 milliseconds. This detonation pattern is designed to break up as much copper-bearing rock as possible. Thanks to technology and carefully designed blasting patterns, the explosive energy fragments the underground rock, minimizing the dispersion of material and dust. After the explosion, the ore loading begins. Gigantic machines lift the material with their large buckets and deposit it into huge mining trucks. To obtain 1 ton of copper, almost 200 tons of ore are extracted. The excavators collect the rock, lifting almost 80 tons at once. This rock contains less than 0.5% copper. The trucks are almost 7 meters tall and have a capacity of up to 400 tons. Since the size of an open-pit mine is enormous, its operation is managed from a control center, which is located in a tower similar to those at airports, from where everything happening on the site can be observed. But how does ore-bearing rock turn into one of the most widely used metals in the world? Releasing copper from the ore requires different techniques depending on whether it is oxide ore or sulfide ore. To process oxide ore, the rocks are stacked in special leaching areas. The material is deposited on the outskirts of the mine to start the leaching process. There they are sprayed with a diluted sulfuric acid solution. For weeks, this acid slowly seeps through the rock, dissolving the copper. The solution loaded with copper ions is collected in tanks and distributed to the processing plant. In a special channel, the copper solution binds to an organic reagent and floats to the surface. Next, an acidic solution is added that increases the concentration of copper and makes it electrically conductive. The solution is transferred to a series of tanks with thin copper plates called cathodes. An electric current is applied, and the copper ions begin to deposit on the plates. In just 10 days, each one reaches a thickness of 2.5 centimeters. The purity reaches almost 100%, which is essential if the copper is to be used to manufacture electrical products. Extracting copper from sulfide ore is a more complex process. It starts in a gigantic drum known as a mill. Inside it, steel balls crush the wet rocks into fragments. When leaving the mill, the material passes through a perforated conveyor that separates the smaller pieces. These fragments then go to secondary mills. The larger stones return to the mill for another round of grinding. Once pulverized, chemicals are added that coat the copper particles, and a foaming substance is mixed in. The mixture enters the flotation tanks, where air bubbles carry the particles to the surface. This copper-rich foam is collected and filtered to obtain a concentrate with a purity of at least 30%. The next step takes place at the smelting plant. The concentrate travels by train to huge yards, where it is layered with silica sand, known as flux. This sand helps remove impurities during smelting. At extreme temperatures, the mixture turns into a glowing liquid. The slag, made up of iron and other minerals, floats while the copper sinks. At this point, it already reaches a purity of 60%. Next, it goes into a second furnace, where the copper content rises to 98%. The molten residue is poured onto a pile, a stream of glowing slag that flows like molten lava. As it cools, it solidifies and becomes part of the landscape. Meanwhile, a crane transports liquid copper to another furnace, where the final purification is carried out. The purity increases to 99%, and the molten copper is poured into molds, forming large rectangular plates called anodes. These plates are cooled with water jets and solidify. A hydraulic cylinder ejects them from the mold, and an automated system transports them to a rinsing station, where the residues of the release agent are removed. Afterwards, they are sent to a refinery hundreds of kilometers away. At the refinery, maximum purity is achieved. The anodes are immersed in tanks with electrolyte and placed in front of thin metal sheets called cathodes. When an electric current is applied, the pure copper transfers from the anodes to the cathodes. The impurities fall to the bottom of the tank. The result is copper with almost 100% purity, suitable for manufacturing high-performance cables. This molten copper is introduced into a vertical furnace. The copper melts and flows to the bottom. From there, it is channeled into a mold that forms rectangular blocks about 6 meters long. The molten copper passes through an opening in the mold and is cooled with water, forming a continuous rectangular bar. Rollers significantly reduce its diameter. As it passes through these grooves, the bar is transformed into a copper rod approximately 7 millimeters thick. The rod leaves the system, and the machine coils it into a spiral shape. Next, a machine compresses the copper coil so that it takes up less space during transportation. This spool of pure copper will be turned into electrical wire, ready to deliver electricity all over the world. And that was today's video. Remember to like and subscribe to the channel.